It is an accepted fact that increased concentrations of atmospheric carbon dioxide is causing global warming. Extreme weather events are leading to increased flooding in temperate zones. Arid regions are experiencing extended periods of drought. Melting ice in the polar regions and retreating glaciers worldwide are leading to sea level rise, threatening millions of people living in low-lying areas. These impacts alone are powerful enough incentives to act, but scientists are only now discovering something possibly even more alarming. A large proportion of the extra carbon dioxide being pumped into the atmosphere is being soaked up by the world's oceans. And the implications of that are potentially catastrophic.
Since the beginning of the Industrial Revolution in the 1800s, the ocean has taken up half of the CO2 that humans have released in the atmosphere. That's a gigantic amount.
I think 500 billion tons of carbon dioxide in the ocean already.
So these are very large changes in the chemistry of the ocean that are unprecedented for many millions of years.
As any chemist will tell you, dissolving carbon dioxide in water reduces its pH, which means the water turns acid. The process works like this. Carbon dioxide from the atmosphere combines with water to form a new compound known as carbonic acid. The same weak acid is found in carbonated drinks. This process decreases the ocean's pH, moving it from the alkaline end of the spectrum towards the acidic end. The challenge scientists now face is determining the impact the ocean's increased acidity will have on marine life.
I know of no evidence that higher carbon dioxide levels are good for life in the ocean. So the real question is, are they a little bit bad or a lot bad? Which animals will be most impacted, which will survive?
Carbon dioxide is most easily taken up by cold water. So the polar areas are thought to be the first to feel the impact of acidification.
The content of CO2 can be much larger in cold waters because CO2 dissolves much easier when the water is cold. So the potential for the high latitude and cold waters to mop up CO2 and to become quickly affected by elevated PCO2 is much higher than in the tropics.
The ocean's ability to adjust to the increased carbon dioxide is severely reduced by the speed at which it is entering the water.
In the next 100 to 200 years, we are going to see very, very large changes in the acidity of the ocean that are larger than has been seen on Earth over at least 20 to 30 million years.
And those changes which occurred in the past were very slow. So there was a lot of time and scope for the organisms to adapt, to evolve to those changing conditions, and now we are changing it in almost an instant.
Organisms most at risk include tropical reefs, cold water corals, and polar plankton communities. Increased water acidity deprives these organisms of carbonate ions, which they need to manufacture their skeletons and shells.
The carbonate concentration is going down, and this is affecting a lot all the organisms relying on this ion for their livelihood, and among those are calcifying organisms. And the rate at which they build this skeleton is declining by, on average, 30% at a CO2 level expected for the end of this century.
Corals are found throughout the world, from tropical shallows to deep in the Arctic. They harbour an incredible diversity of marine life. They are known as the rainforests of the sea and play a crucial role in the ocean ecosystem, acting as nurseries for juvenile fish. Less well known are these small marine butterfly snails. Unlike their bottom-dwelling relatives, these tiny creatures live in the upper water layers of the oceans, especially in polar seas. These animals can form vast planktonic swarms, which constitute a major food source for fish and marine mammals, including some species of whale. Ocean acidification threatens thousands of species. It's expected the entire ocean food chain will be affected.
Any group that calcifies, that makes calcium carbonate skeletons, shellfish, small plankton that are the basis of food change in the ocean. And we don't know if we'll see a reduction in their abundance that leads to a reduction in primary productivity and ocean productivity for important marine fisheries.
Over 2.5 billion people worldwide rely on fish for food. If plankton are damaged by ocean acidification, it may well be the last straw for the fish that feed on them, already stressed by increased marine pollution, rising sea temperature and overfishing.
Pollution, temperature, and CO2, if we look at those three things together, we know that we have a very bad formula for disaster down the road if we don't do something about our CO2 emissions.
Solutions are a global problem. Even if carbon dioxide emissions were stopped today, the oceans would take 30 years to respond. Raising awareness of ocean acidification is just a first step.
We need to bring the public much more into an understanding of what's going on. Ocean acidification is really unknown to most people and to most governments, and it needs to become much more a part of the climate change dialogue.
In the next 100 years or so, the lifetime of my son, who's now 7, he will see very large changes in the ocean. It will change more in the lifetime of our children than we've seen for the last 20 to 30 million years.